So when I see the word limit, I know that I'm going to take some limit. Okay? Alright, so the thing goes the following. So suppose I have two series, AK, k from 1 to infinity, and BK, k from 1 to infinity, and assuming that AK and BK are all positive. Okay. Now I'm going to take the limit of AK over BK. K go to infinity. So this is called limit. So suppose this limit exists equal to a number, and this number is not 0. Then these two series are either both convergent or both divergent. If the limit of these two series is a number, is a limit, is a number, and that number, if in other words, this limit exists and it is not equal to 0, not 0, it's very important, not equal to 0, then these two series are either both convergent or both divergent. And this is page 645. 645. And of course, this is not the whole thing, it's still small. But just write this where this is. Page 645. This is a theory. 8.17. 8.17. Okay. Now, so 1 is this, right? Now, what if the limit is 0, infinity? What happens? Okay, so I'm going to continue. So 2 is page 6. Right? Suppose this limit AK over BK, K goes to infinity, is L, but L is 0. Yeah, because before we say that it is not 0, it exists not 0. And then so both are either convergent or both are divergent. Now, what happens if this is equal to 0? Well, if this is equal to 0, what happens is that then if the series BK is convergent, then the series AK is convergent. Now this is easy to understand because what this means, namely the limit of AK over BK goes to 0, that means AK is smaller than BK. So that's the only way for this to go to 0, is that AK is smaller than BK. And then from the previous comparison test, we know that if the larger one, BK, if the larger one is convergent, then the smaller one is convergent. So this is from comparison test. Well, what happens if this equals infinity? What if this is infinity? Infinity means AK is larger than BK, right? Normally it's much larger than BK. So if BK is divergent, because this means AK is larger than BK, AK is bigger than BK, AK is, so that's the only possibility that this will go to infinity. So if that is the case, then if this is larger than, now, so if BK is smaller one, is divergent, then you cannot add up the smaller one. Then you cannot add up the larger one. Okay. And this is the comparison test. Okay. It's not difficult to understand it because all this really comes from common sense. Common sense means that if you can add larger numbers, you certainly can add smaller numbers. But if you cannot add the smaller numbers, you cannot add larger numbers. Okay, well, I guess today because we have to cover section 8.5 and 8.6, so probably I think we should just go all the way to exercise. Okay. Sometimes I'll refer to this for the thing. Okay, so I'm going to look at exercise 8.5. So 8.5, that's 9 to 37 R. Okay, so I'm going to look at the number 9, and it tells me that use the ratio test. Okay, number 9, use the ratio test. Okay, so summation 1 over k factorial, k from 1 to infinity. The question is this convergent? Okay, use the ratio test to determine whether the series, the following series converge. Okay, all right. So so let us review. So what the ratio test says. Ratio test says that this is that if I take this limit, right? If either the limit exists or limit doesn't exist. If limit doesn't exist, divergent. If it exists and the limit is bigger than 1 is divergent, smaller than 1 is convergent, equivalent in conclusion. Okay? Alright. So first of all, we have to do everything very carefully. Write everything down. Okay? 1 over k factorial. What is a sub k plus 1? 1 over k plus 1 factorial. Okay? Now, what is a sub k plus 1 over a sub k? Keep in mind, this must be the k plus 1 term over the k term. You cannot mix these two up, okay? Then take a limit. Alright, no more, right? So this guy is this guy. So this becomes k factorial divided by k plus 1 factorial. Right? Okay? Alright, so I need to do some cancellation here. What's k factorial? Okay, it's 1 times 2 times 3 all the way to k, right? That's k factorial. What is k plus 1 factorial? 1 times 2 times 3 all the way to k, but not enough, all the way to k plus 1. Okay? Alright, so I'm taking the limit of this. Limit of this. And the limit of this. Okay? Alright, well, let's cancel things, right? That's those are cancel. Okay, and the only thing left over is 1 over k plus 1. When k goes to infinity, infinity 1, 0. 0 is less than 1 because it says if the limit exists, if it's less than 1, it's convergent. This 0 is less than 1, right? So therefore, the answer is convergent. Okay, this is a ratio test. right? Let's look at maybe another one, okay? So how about 15, number 15? Okay, the series is 2 to the k, 2 to the k over k to the 99, something, right? 99, 2 to the k, k to the 99, k is from 1 to infinity, okay? The question is this convergent?
Can you move it down a little bit?
Okay? Okay, so what is a sub k? So presuming about this one, right? Okay, so what is a sub k plus 1? Because they told us to use ratio test. So k plus is when I replace k by k plus 1. So this is 2 to the k plus 1. K plus 1 to 99. So I'm going to take the limit k goes to infinity, okay? Of a sub k plus 1 over a sub k. A sub k plus 1 is 2 to the k plus 1 over k plus 1 to the 99. And this is 2 to the k over k to 99. So this limit k goes to infinity. And then, okay, so when this multiply this, this multiply like this, right? So 2 to the k plus 1, k to 99 equal to 2 to the k plus 1 to the 99. Here I use the algebra you probably remember it's a, if a over b divided by c over d. This is AD times BC. Okay. Yeah, if I have A divided by B divided by C, it's AD times BC. Okay, that's the algebra we use here. A divided by B over C divided by B, that's AD times BC. I'm AD divided by BC. Okay, well, once I have this, then the next thing I need to do is to do some cancellations. So, I have 2 to the k here. Cancel with this 2 to the k, so I have 2 left. Because 2 to the k plus 1 is 2 to the k times 2. 2 to the k cancel, I have 2 left. Alright, so I have 2 here, and this is k, right? K over k plus 1. And both are 99. Okay? And so this is equal to 2. I can bring the limit into this because 2 has nothing to do with the limit anyway. This one, limit k over k plus 1 here, you can use L'Hopital rule to find out what this is. So this is limit k goes to infinity. You differentiate k, right? This is 1. Differentiate k plus 1 is also 1. So here, remember I use L'Hopital rule. Okay, L'Hopital rule. That's 1 over 1 is 1. 1 to 99 is 1. 1 times 2 is 2. Okay, 2 is what? Bigger than 1. So, now for the ratio test, if the limit is bigger than 1, it is what? Ratio test. If the limit is bigger than 1, it is divergent. Okay? Therefore, for this method, divergent. Okay? Alright, so this is